Hello everyone. In this video, we are going to be going through how to graph some more complex cubic functions. Now, in the last video, we walked through some examples where our cubic function was already factorized. Now, we do not always get our equations in their factorized form. So in this video, we are going to be going through how we can convert an equation such as this into its factorized form so that we can graph it without a calculator much more easily. Now, the very first thing we do is we try to figure out an x-intercept of this equation using substitution. Now, we know that at the x-intercept of any graph, the y value will always equal 0. So at any x-intercept of any graph, your y value will always equal 0. So we know if we take p of x as our example over here, we know that this must equal 0 at its x-intercept. Now, generally, this step involves a bit of trial and error. Unfortunately, there's nothing much we can do about this. It's just the way this first step works. But if we're preparing for a VCE exam, for example, you'll generally find that the number that you're substituting into these equations aren't very large. Okay, let's start by substituting in 1. If we have an x-intercept, so if we have an x-intercept at x equals 1, we know that our p of x will equal 0. So this is what we're trying to prove over here, or this is what we're trying to determine, that if we have an x-intercept at x equals 1, well, substituting the 1 into the equation should give us 0. So let's try and see if this works. So p of 1 would be equal to 1 to the power of 3 plus 5 times 1 to the power of 2 minus 1 minus 5. Let me move this down to make it a bit clearer. Okay. 1 to the power of 3 is simply 1, plus 5 to the power of 1 is also 5 times 1 to the power of 2 is the same thing as 5 times 1 minus 1 minus 5. So this would equal 1 plus 5 minus 1 minus 5. Look at this. These two cancel out, so 1 minus 1 equals 0, and 5 minus 5 also equals 0. So we know that p of 1 equals 0. So this confirms through substitution that x equals 1 will be an x-intercept of this graph. Now, in the last video, we walked through the null factor law. The null factor law allows us to separate each of the multiples of our cubic graphs into separate equations. So, for example, if we have 0 equals x minus 3, x minus 5, x minus 6, then the null factor law allows us to split these into equations. So it allows us to split these into separate equations of 0 equals x minus 3, 0 equals x minus 5, and 0 equals x minus 6. From this, we can rearrange for x. So this one would give us x equals 3, this one would give us x equals 5, and this one would give us x equals 6. Now, in a similar way, we're working backwards over here. So we are working backwards over here. We already know that x will equal 1. What we will do now is rearrange the equation to give us something in this form. So let me demonstrate. We already know that x equals 1, but we want to extract our factor from this equation. The way to do this is by rearranging this equation to make it equal 0. So if we minus 1 from both sides, we get x minus 1 equals 0, meaning that one of our factors will be x minus 1. So now we can rewrite p of x as x minus 1, one of the factors, times another quadratic equation. Now step number 2 would be to determine the quadratic multiple. Now, the way that we determine the quadratic multiple is via long division. So, long division with polynomials. Long division with polynomials. Now, if you do not know how to do long division with polynomials, I will most likely be creating a separate video for this, so keep an eye out for that one. But for now, let's just quickly walk through the steps of long division with polynomials without too much explanation. So we know that p of x in its expanded form will be x to the power of 3 plus 5x squared minus x minus 5. So this was given to us in the original question. So this was the original equation given to us. We know that one of the factors in its factorized form would be x minus 1, and it will be multiplied by an unknown quadratic. Our job is to determine this unknown quadratic. So to isolate the unknown quadratic and determine it, we will have to divide both sides by x minus 1. So if we divide this side by x minus 1, then these two will just cancel out, isolating our quadratic, which is what we're trying to determine. And we will have to divide this side by x minus 1. So this can be simplified using our long division. Alrighty, let's set this long division up as we normally do. So x to the power of 3 plus 5x squared minus x minus 5 divided by x minus 1. Okay, first step of long division with polynomials, we are going to ask ourselves, x times what equals x to the power of 3? Okay, by now, intuitively, you should know that x times x to the power of 2, so x times x to the power of 2 should equal x to the power of 3. Okay, now we will use this x to the power of 2 and expand it into our denominator. So this would be x to the power of 2 times x minus 1. So this should give us x to the power of 3 minus x squared. This term is what we are going to be minusing from our original equation to determine our new equation that we're going to work with for the next term. So x to the power of 3 minus x to the power of 3 is just 0. 5x squared minus x squared. So again, taking note of the double negative over here. So minus x squared. So if we expand this in, this essentially means 5x squared plus x squared. So 5x squared plus x squared should give us 6x squared. And the rest of the equation should remain the same. So the rest of the equation is minus x minus 5. Okay, let me neaten this up a little bit for our next step. Okay, now we will be doing the exact same thing, only we are dealing with the next term of our newly formed equation, which is 6x squared. So we will ask ourselves, this x times what will give us 6x squared? So x times what will give us 6x squared? Again, intuitively, you should know that x times 6x should equal, so x times positive 6x should equal positive 6x squared. Again, what we're going to do is we're going to expand the 6x over here into our denominator. This would give us 6x squared minus 6x. again, this is the term that we are minusing from this equation that we formed when we were dealing with the last term. So 6x squared minus 6x squared would give us 0. So that gives us 0. And negative x minus 6x, so minus 6x or minus negative 6x is the same thing as plus 6x. So negative x plus 6x should give us positive 5x. This should equal positive 5x. Again, the remainder of the last equation would remain the same, so minus 5. And let me neaten this up once more, and we will repeat the process for the next term. Okay, so we are asking ourselves the same question this time. So x times what would give us 5x? So remembering that we're always looking at the newly formed equation. So x times what equals positive 5x. Again, intuitively by now we should know that x times 5. So x times positive 5 should give us 5x. So this x times positive 5 should give us positive 5x. Now, we will again expand this positive 5 over here into the denominator. So that should give us 5x minus 5. And this will be the term that we will minus from this other equation. So this is being minused from this equation, remembering our brackets. And we know that positive 5x minus 5x would equal 0. And we know that negative 5x minus negative 5, I misspoke over there. We know that negative 5 minus negative 5 is the same thing as negative 5 plus 5. So negative 5 plus 5 also equals 0. Okay, so this means that we have no remainders and we have figured out our quadratic multiple. Okay, now we can rewrite p of x in our partially factorized form now. In step number 1, through substitution, we determined that x minus 1 would be a factor. So x minus 1 was a factor, and now we know what our quadratic factor is. So that is x to the power of 2 plus 6x plus 5. Alrighty, now last step would be now to factorize the quadratic. This is our last step. Now we factorize the quadratic. Okay, so when we factorize quadratics, we look at the 5 over here. So we look at our c value, and we try to determine numbers that multiply to give us 5, but add to give us 6. Now this one is fairly obvious. We know that 5 and 1, when we multiply them together, they give us 5. So 5 times 1 equals 5. So 5 times 1 equals our c value. And when we add these two together, so 5 plus 1 equals 6. So 5 plus 1 equals our b value. This means that our two factors for this quadratic would be x plus 5 from here and x plus 1. And from the very first step that we did before, our factor that we found there was x minus 1. Okay, now that we have p of x in its factorized form, we can go ahead and graph this much more easily. From this, we can see that we will have 3 x-intercepts at x equals 1, x equals negative 5, and x equals negative 1. So graphing factorized cubic graphs, I did go through in the last video. So if you do need a bit more explanation on this, feel free to have a look. Okay. we know that our three x-intercepts will be at 1, -5, and -1. So let's make note of those on our graph. So 1, -1, and -5 should be over here. Okay. To figure out our y-intercept, we make our x equals 0. Now, to figure out the y-intercept, it would be a lot easier to substitute the x equals 0 into the expanded form that we were originally given. So your p of x in its expanded form, was x to the power of 3 plus 5x minus x minus 5. If we substitute in 0, x equals 0, we get 0 to the power of 3 plus 5 times 0, oh, that should have a square, minus 0 minus 5. So this should give us p of 0 equals -5. So your y-intercept will be at -5, somewhere down here. So I'm not entirely drawing this to scale. This is just to give us a rough idea. Let me move this stuff over. Okay. Because we don't have a negative out the front of the equation or out the front of any of these x's, we know that this graph will start by sloping upwards. It will pass the x-axis at the first x-intercept at x equals -5 before curving back down to pass through the x-axis at x equals -1. Let me draw this a bit neater. And it will slope down to y equals -5 before coming back up to pass the x-axis at the last x-intercept of x equals 1. So if we take note of all of our intercepts, this would be 1, 0, this would be -1, 0, this would be -5, 0, and this here would be 0, -5. Okay. Hopefully this video gave you a bit of an overview on how to graph some more complex cubic functions that won't always be given to you in their factorized form. As always, feel free to let me know if you have any questions. Otherwise, I will see you next time.